The standard quadratic function is given by f of x is equal to ax squared plus bx plus c, where a, b, and c are numbers. You can also write it as y is equal to ax squared plus bx plus c. When you graph this, you will have a parabola. So a parabola might look like that if it opens up. It might look like this if it opens down. If the parabola opens up, this would be the vertex and it would be the lowest point, so V for vertex. If the parabola opens down, this would be the highest point. The highest point, I'll call that V, the vertex is the highest point. So what did I say? If the parabola opens up, then the vertex is the lowest point. If the parabola opens down, then the vertex is the highest point. How do I find the coordinates of the vertex? The x-coordinate of the vertex is negative b over 2a. The y-coordinate of the vertex is f evaluated at negative b over 2a. So that's how you find the coordinates of the vertex. So for example, tell me about f of x is equal to x squared plus 5x plus 4. What is the vertex? So to find the vertex, the x-coordinate, negative b over 2a. In this case, that's negative, what's b? A would be the coefficient on x squared, that's 1 in this case. B would be the coefficient on x, that's 5. So b is 5. Okay, the denominator is 2 times a. A is the coefficient on x squared, so that will be 1. What? So this will be negative 5 over 2. So now to find the y-coordinate, I evaluate f at negative 5 over 2. So that will be negative 5 over 2 squared plus 5 times negative 5 over 2 plus 4. So what does this turn out to be? Negative 9/4. Negative 9/4. So the vertex is given by negative 5/2, comma, negative 9/4. Or if they want decimals, negative 2.5, comma, negative 2.25. So there you have it, that's the vertex. Does this parabola open up or down? The lead coefficient is 1, isn't it? A is equal to 1. Since A is positive, that means that the parabola opens up. It opens up. They might also ask what the x-intercepts are. So x-intercepts. X-intercept or intercepts. That's where it crosses the x-axis. That would be where y is 0. So f of x, that's y. So I'd have 0 is equal to x squared plus 5x plus 4. I could use the quadratic formula to solve this, or of course I could just factor this. So 0 is equal to x plus 1 times x plus 4. If I factor it, that's what it becomes. Solve this. If you solve this equation, you get x is negative 1. You get x is negative 4. So what does that mean? So the x-intercepts are negative 1, comma 0 and negative 4, comma 0. Those are the x-intercepts. Well, what are the y-intercepts? The y-intercepts, int for intercept, that's where it crosses the y-axis at that location. I say where. I wrote it kind of sloppy. Where, W-H-E-R-E, where x is equal to 0. So I'm looking for f of 0. That's 0 squared plus 5 times 0 plus 4, which is obviously 4, isn't it? So the y-intercept is 0, 4. That's where it crosses the y-axis. So now I have enough information to graph this. Well, to graph this, I create the coordinate plane. What did I say the x-intercepts were? -1 and -4. So 1, 2, 3, 4, 5. This is a little crooked, I'm sorry. Okay, so the x-intercept, -1 right there, and -4 right there. Those are the two x-intercepts. What is the y-intercept? 4. 1, 2, 3, 4. So here's the y-intercept right here. That's 4 right there. What was the vertex? The vertex was -2.5, so 1, 2, 2.5. 1, 2, 3, -3. The y-coordinate of the vertex was -2.25, so that's about here. So right there, the coordinates of that point are -2.5, -2.25. That's the vertex right there. How does that look? And I already said that the parabola opens up. So when I connect the dots, I think I have enough dots to connect here. It'll look much better when you do it in a computer. So roughly, that's what the graph of this parabola looks like. Okay, tell me everything you need to know about f of x is equal to -3x squared plus 17x minus 10. So what's the first thing that I should do here? Find the vertex? How do you find the vertex? How do you find the x-coordinate of the vertex? Okay, so vertex. The x-coordinate is -b/2a. Okay, so what is b in this case? Okay, so the formula, ax squared plus bx, can you see this? Plus c. So a is like -3, b is like 17, c is like -10. So the b part is 17. In the denominator, 2 times a is -3. Okay, how is that? So this will turn out to be 17/6. Okay, 17/6, you satisfied with that? The decimal equivalent of that is 2.83, where the 3 repeats. You can't see it. Okay, now you can. Okay, so 17/6, that's the x-coordinate of the vertex. How to find the y-coordinate? So the y-coordinate, I'll move my giant hand in a minute. You have to find f evaluated at the x value I just found, so that's 17/6. Okay, so stick 17/6 in there, in here. Well, it'll be -3 times 17/6 squared plus 17 times 17/6 minus 10. Okay, how is that? So if you do this calculation, you'll find that it's 169/12. See it there? What's the decimal equivalency for that? The decimal equivalent is 14.083 with a repeater bar above the 3. Okay, so what is the vertex of this then? What is the vertex? Okay, so this is the vertex, 17/6, 169/12. Or I could give the decimal equivalencies. So this is the vertex I just found. Okay, how was that? Okay, now does this parabola open up or down? What? The lead coefficient is negative, meaning that it opens down, doesn't it? Okay, so I'll say it opens down. And the reason for that is because the lead coefficient, or I could just say a, is less than 0. So it opens down. Okay, what is the x-intercept for this parabola? The x-intercept for this, how do I find that? I have to set it equal to 0, don't I? Okay, so to find the x-intercept, x-intercept is where y is equal to 0. Or what y? What am I talking about? You understand that f of x could be rewritten as y if I wanted. So I could say y is equal to negative 3x squared plus 17x minus 10. Okay, put 0 on the left-hand side of this. Okay, so my mission is to solve this. Okay, solve that for me. So this is what I'm trying to solve. Negative 3x squared plus 17x minus 10. Get the focus here. How was that? Okay, negative 3x squared plus 17x minus 10 is 0. Solve that. So remember, I want ax squared plus bx plus c. So a in this case is like negative 3, b is like 17, and c is like negative 10. Have you heard of the quadratic formula? That's the quadratic formula. So to solve this, I use the quadratic formula. So here it is. X is negative b, 17 is b, plus or minus the square root of b squared minus 4 times a times c divided by 2a. Okay, let me simplify this expression. The radicand becomes 169, so all that stuff under the radical sign becomes 169. Okay, what is the square root of 169? 13. So this becomes negative 17 plus or minus 13 divided by negative 6. If you use the plus sign, you'll have negative 17 plus 13, which is negative 4. Negative 4 over negative 6 is 2/3. If you use the minus sign, negative 17 minus 13 is negative 30. Negative 30 over negative 6 is positive 5. So this tells me what the vertices are. Not the vertices, I mean the x-intercepts, pardon me. The x-intercepts are 2/3 comma 0, that's from this, 2/3, and the other one is 5 comma 0. So these are the x-intercepts. And now the y-intercept is if x is equal to 0. So if x is equal to 0, that means you're finding f of 0. F of 0, so you're sticking 0 in place of x for the original function. So what I will have is negative 3 times 0 squared plus 17 times 0 minus 10, and that will give me negative 10, as you can see. The first term goes to 0, the second term goes to 0, so that leaves me with negative 10. What? Okay, so the y-intercept is 0, negative 10. How does that look? Okay, now what are all the things I know about this function? Okay, so here's the coordinate plane. I made it big enough to contain all the relevant information. Okay, now have you copied this down? All this stuff I've been doing? What is the vertex? It was about 2.8 comma 14.1 approximately. So 2.83 approximately for the x-coordinate of the vertex. That's about here. And then the y-coordinate of the vertex. Notice that the tick marks are 2 feet apart from each other. 2 feet, 2 inches, whatever unit you want to deal with. 2, 4, 6, 8, 10, 12, 14. So the vertex was right there. Remember I found the vertex a long time ago? 2.83 with a repeater bar above the 3. And 14.083 with a repeater bar above the 3 was the y-coordinate. So that's the vertex. Remember I found that a long time ago? I know that it opens down because the lead coefficient was negative. The x-intercepts were 2/3 comma 0, so that's approximately here. 2/3 0. And the other one was 5 0. So this is 1, 2, 3, 4, 5. Here's 5 right here. So that's 3 points right there. Okay, and I just determined that the y-intercept is 0, negative 10. So 0, negative 10, the y-axis is in increments of 2. So 2, 4, 6, 8, 10. Here the y-intercept is right there. Y-intercept right here. That's 0, negative 10. Here I'll put it on this side. That's the y-intercept. Okay, how many points do I have? I've got the vertex, I've got the two x-intercepts, and I've got the y-intercept. So now I'm going to connect the dots. Just like that, I connect the dots. So I've got this parabola right here. I did it by hand, so it's not particularly neat. Let me zoom out so you can see it better. Okay, so this is the parabola. First I found the vertex, then I found the x-intercepts, then I found the y-intercept. I know it opens down. So this is what the graph of the function looks like.